Look around you. What do you see? Take a moment to absorb the scene. Maybe a chair, a book, or the face of a friend. These are everyday objects, familiar and comforting. Now imagine shrinking down to an impossibly small size. Picture yourself becoming smaller and smaller until the world as you know it fades away. As you journey into the heart of matter, you'd witness a hidden universe teeming with activity. This is a world where particles dance and interact in ways that are both mysterious and mesmerizing. This is the realm of atoms, the fundamental building blocks of everything we see, touch, and feel. These tiny entities are the foundation of all matter. Atoms are the smallest unit of an element that retains the chemical properties of that element. They are like the individual letters in the alphabet of the universe. Everything in the universe, from the air we breathe to the stars in the night sky, is made up of atoms. But why atoms? What makes them so special? What makes these tiny particles so fundamental to the fabric of reality? The answer lies in their unique properties and interactions. The answer lies in the unique ability of atoms to combine and form complex structures. These combinations are the essence of chemistry and the basis of life itself. Like the letters of an alphabet, a finite number of atom types can be arranged and rearranged to create the astonishing diversity of our universe. Each arrangement brings forth new properties and possibilities. Think of it this way. Just as a few musical notes can create an infinite variety of melodies, atoms are the notes from which the grand symphony of the cosmos is composed. Each note or atom plays a crucial role in the harmony of existence. In the sections that follow, we'll embark on a captivating journey into the world of atoms, exploring their history, their structure, and their profound impact on the universe we call home. We'll delve into the stories of how these tiny particles were discovered, how they interact, and how they shape everything around us. Prepare to be amazed by the intricate dance of atoms, a dance that has been going on since the dawn of time and continues to shape our reality every moment of every day. The idea of atoms has been around for millennia. Ancient Greek philosophers, particularly Democritus, first proposed the concept of indivisible particles called atomos, meaning uncuttable. They believed that all matter was composed of these tiny, indestructible units. However, it wasn't until the 19th and 20th centuries that the existence of atoms was scientifically confirmed. Scientists like John Dalton, J.J. Thomson, Ernest Rutherford, and Niels Bohr made groundbreaking discoveries that revealed the true nature of atoms. Through a series of ingenious experiments, these pioneers peeled back the layers of the atom, revealing its internal structure. They showed that atoms were not, in fact, indivisible, but composed of even smaller particles, protons, neutrons, and electrons. These discoveries revolutionized our understanding of the universe. They provided the foundation for modern chemistry and physics, and they opened up new avenues of exploration into the nature of matter and energy. Imagine the atom as a bustling city. At its heart lies the nucleus, a dense and compact region akin to the city center. The nucleus is home to two types of particles, protons and neutrons. Protons, positively charged particles, determine the atomic number of an element, a fundamental identifier in the world of atoms. Neutrons, on the other hand, carry no charge, contributing to the atom's mass but not its electrical properties. Orbiting the nucleus, much like planets around a star, are electrons. These negatively charged particles are much lighter than protons and neutrons, constantly in motion around the nucleus. The arrangement and behavior of these electrons determine the atom's chemical properties. The balance between the positive charge of the protons and the negative charge of the electrons keeps the atom electrically neutral. This delicate balance of forces within the atom is crucial for the stability of matter as we know it. Section 4. The Architects of Matter: How Subatomic Particles Build Our World. In this section, we delve into the fascinating world of subatomic particles, the fundamental building blocks that construct everything around us. Each of the subatomic particles plays a crucial role in shaping the properties of matter. These tiny entities, though invisible to the naked eye, are the architects of the universe, determining the characteristics and behaviors of all substances. Protons, with their positive charge, determine the element to which an atom belongs. The number of protons in the nucleus of an atom is known as the atomic number, and it is this number that defines the identity of the element. For instance, an atom with 1 proton is always hydrogen, while an atom with 6 protons is always carbon. This fundamental property is what makes each element unique and allows for the vast diversity of matter in the universe. Neutrons, while not affecting the atom's electrical charge, influence its mass and stability. They act as the glue that holds the nucleus together, preventing the positively charged protons from repelling each other. The number of neutrons in an atom can vary, giving rise to isotopes, atoms of the same element with different numbers of neutrons. Isotopes can have significant implications in fields such as medicine, archaeology, and environmental science. Electrons, the nimble dancers of the atomic world, are responsible for an atom's chemical behavior. These negatively charged particles orbit the nucleus at various energy levels, creating a dynamic and ever-changing environment. Their interactions with electrons from other atoms lead to the formation of chemical bonds, the glue that holds molecules together. These bonds can be ionic, covalent, or metallic, each with its own unique properties and significance. The unique arrangement of electrons in different atoms dictates how these atoms will interact with each other. This arrangement is governed by the principles of quantum mechanics, which describe the behavior of particles at the smallest scales. This interplay of attraction and repulsion between electrons gives rise to the incredible diversity of chemical compounds that make up our world. From the simplest molecules like water to complex organic compounds, the interactions of subatomic particles are at the heart of all chemical processes. Section 5. The dance of atoms. Bonds, energy, and the creation of molecules. Atoms are not solitary entities. They are social creatures, constantly interacting and forming bonds with one another. The driving force behind these interactions is the desire to achieve a stable electron configuration, often by sharing or transferring electrons with other atoms. This sharing or transferring of electrons leads to the formation of chemical bonds, the forces that hold atoms together within molecules. These bonds are not rigid connections. Rather, they are dynamic interactions that involve the constant movement and exchange of energy. When chemical bonds are formed or broken, energy is either released or absorbed. This exchange of energy is what fuels countless processes in the universe, from the burning of a candle to the complex chemical reactions that power our bodies. Section 6. A universe of variety, from simple atoms to complex life. The beauty of the atomic world lies in its elegant simplicity. At the heart of everything, from the smallest grain of sand to the vastness of the cosmos, are atoms, the fundamental building blocks of matter. With a limited number of elements, each characterized by its unique atomic structure, an astounding array of molecules and materials can be created. These elements, organized in the periodic table, each have distinct properties that dictate how they interact with one another. Just as 26 letters of the alphabet can be combined to form an infinite number of words, atoms can be arranged and rearranged to form the building blocks of everything we see around us. This combinatorial potential is what makes chemistry so fascinating and powerful. Consider water, a simple yet essential molecule for life. Despite its simplicity, water is fundamental to the existence of life as we know it. It's composed of just two elements, hydrogen and oxygen. These two elements, when bonded together, create a molecule that is vital for countless biological processes. Two hydrogen atoms bond with one oxygen atom, forming the familiar H2O molecule. This simple molecular structure is responsible for water's unique properties, such as its high surface tension and its ability to exist in three states: solid, liquid, and gas. This seemingly simple arrangement of atoms gives water its unique properties, from its ability to dissolve a wide range of substances to its role as a universal solvent in living organisms. Water's polarity allows it to interact with various molecules, making it indispensable for life. From the air we breathe to the food we eat, every substance we encounter is a testament to the astonishing combinatorial power of atoms. The oxygen we inhale and the nutrients we consume are all products of atomic interactions. The complexity of life itself arises from the intricate dance of atoms, forming molecules, macromolecules, and eventually, the complex machinery of living cells. These cells in turn build tissues, organs, and entire organisms, showcasing the incredible potential of atomic combinations. At the core of this complexity is DNA, the molecule that carries the genetic instructions for life. DNA itself is a marvel of atomic arrangement, with its double helix structure formed by sequences of nucleotides. These sequences determine the traits and functions of every living organism, highlighting the profound impact of atomic interactions on the diversity of life. Over billions of years, these atomic interactions have driven the evolution of life, leading to the vast array of species we see today. From single-celled organisms to complex multicellular life forms, the journey from simple atoms to complex life is a testament to the power of chemistry. As we continue to explore and understand the atomic world, we uncover more about the fundamental processes that govern life. This knowledge not only deepens our appreciation for the natural world, but also drives innovations in medicine, technology, and environmental conservation. The study of atoms and their interactions remains at the forefront of scientific discovery, promising new breakthroughs that could transform our understanding of the universe and our place within it. From the smallest particles to the vastness of space, the journey of atoms continues to inspire and challenge us, revealing the intricate tapestry of life and the universe.